Hello, my name is Eric. I have a bachelor's in electrical engineering and currently I work as an electrical instrumentation and controls engineer. Today we'll be going over the topics of both mathematics and circuits. This will be more tailored for electrical engineers, but this is good refreshers for other disciplines like mechanical and chemical and any other discipline that heavily utilizes math. So let's get it started. So the topic for today will be complex numbers. The differentiation between the version of rectangular form, polar form, and exponential form is that, and we'll be mainly primarily focused on these two. But for rectangular form, essentially, a good way of thinking of it is that you have a two set points. So let's call this one point, let's call this the other. And essentially what your rectangular form is telling you is that this is your x value and this is your y value. But in reality, these are the three in this case would be your real values and the four would be your imaginary values. And what we're doing is we're saying the distance to get from point A to point B in this case would be 3, and then to get there is 4, right? Now, what we also want to know how to do is how do we go from A to B in a much shorter distance and also the direction we'll be facing to get there. So for polar form, what we're essentially doing is we're going from here to directly to here, right? Which is a much more efficient way of going about it, right? And the way you would convert your rectangular form to polar form is that you're essentially what you're going to do is you're going to take your this angle, and this is the direction you'll be facing to get from point A to point B, and you also need this distance, so let's call it y. And to get your y value first, what you're going to do is you're going to take this x value, you're going to square it, you're going to add it to your, take the square of the y value, and then take the square root of both, which in this case, 3 squared is 9, plus 4 squared is 16, square root of both is square root of 25, which gives you 5. So in this case, our polar form from rectangular form right now is 5. And then to get the angle or the direction we'll be facing, what we're going to do is we're going to take the inverse tangent of this. So if you ever remember doing SOHCAHTOA, so SOHCAHTOA. So essentially in this case, what we want to do is if we want to find this angle, we're going to have to take the inverse tangent of 4 over 3, right? So opposite over adjacent. So this is your opposite value, this is your adjacent value. So if we take 5 tangent inverse of 4 over 3, and if you have a calculator, you can do this. So we take the inverse tangent of 4 over 3. This should give us 5, and then in polar form, you write it like this, and then you go 53.13 degrees. So that's how you convert from rectangular to polar form. Awesome. Now, what we're going to do is next is when you see problems like these, where if let's say we have the rectangular form of two functions. So in this case, we have 3 plus 4j, and then we are given to add or subtract to another rectangular form. So let's call it minus 1 plus 2j. If I were to add these two rectangular forms, you essentially just do it how you typically do it. So you just do 3 minus 1, which gives you 2, and then 4 plus 2, which gives you 6j. And it's the same thing. If I were to convert this to now polar form, you would first do the 2 squared plus 6 squared, take the square root of that, and then you would take the inverse tangent of 6 over 2, and that would give you the angle and the direction you'll be facing to get to your coordinate. Now, what makes this tricky is that when you're multiplying by two rectangular forms, it won't give you the exact numbers that you're looking for. It will actually give you the wrong solution a lot of the times. And the reason why is because you're essentially taking an angle, if you think about it, and you'll be multiplying or dividing them, which typically never works out, right? So what you want to first do is, if I have, in this case, the 3 plus 4 j, so 3 is my real, 4 is my imaginary, and let's say I multiply it by something completely different now. So let's call it 5 minus 2j. Now this will give me a different solution if I were to go about it. So what you want to first do is you want to take the polar form of both of these and then multiply by the 2. So you already know the first one, so we can just write it down. And the inverse tangent is 53.13 degrees. And then what we want to do is now we want the polar form of this, right? So remember the equation we used, so 5 squared minus 2, or sorry, so we add the minus squared 2 squared of this, so negative 2 squared will give us positive, and then we take the square root of that. So we would do 5 squared plus 2 squared, square root of that, which gives us 5.38. So this is this value, so it gives us 5.38. And then if we want the angle, we're going to do the inverse tangent of negative 2 over 5. So if you put that in your calculator as well, what you should get is negative 21.80. So now that's your angle, right? Now we're still not done. So now what we got to do is we got to multiply this polar form by this polar form. So what's nice is we can multiply these two values. So 5 times 5.38, which will give us 26.9. And then here what we do is when you have angles, when you're told to multiply them, what you really do is you add them. So in this case, we take 53.13 and we add it, or in this case, we subtract by 21.86 because it's a negative value, or it's 28.80, sorry. And that will give us the angle of 31.33 degrees. So that's how we do that. Now, if you were to divide, so let's say in this case we were told to divide these two. What we really do is we actually subtract. So these two values we divide, whatever that number would be, but these two we subtract. So it would actually be 53.13 degrees minus this would be a positive, which would be 53.13 plus 21 would give you somewhere between 74.93, something like that. So that's how you do this, and we will get to the last subject involving this and how this involves in circuits. So one thing I forgot to mention from the last problem is that if let's say a question were to ask, now convert the polar form back to rectangular form, what you would do is you would take your magnitude, which in this case would be 26.9. This is, by the way, from the problem we just did. So 26.9. We take the cosine of the angle, which is 31.33. And then we add it by J sine, it would be the magnitude again, which is 26.9, J sine of 31.33. So if you have a calculator, and we did this, and we hand punched this, what we get is 26.9 times cosine of 31.33, which gives us 22.97. And then plus, in this case, our J value would be 26.9 times sine 31.33, which gives us a J of 13.98. So that's how we would convert from polar to rectangular form. So we're going to get to the final thing for this video, which is now taking everything we just learned and now getting that involved with a circuits problem. So if I have a resistor, an inductor, and a capacitor in series, and this will involve complex numbers, especially since we have an inductor and capacitor involved. And typically for these kinds of problems, you would be given the frequency. So in this case, I kept it easy, which in this case would be 60 hertz. So if everything's in series, what happens is a resistor will stay at 10 ohms. Now for our inductor, for 25 milliamps, what the equation for an inductor is J omega L, and a capacitor in series is actually 1 over J omega C. And so what we would do is we have 10 ohms. We add it to our inductor value, which in this case is J. Now our omega or frequency, our omega value, how we would get it is that omega is equal to 2 pi times the frequency. So if our frequency is 60 hertz, all we have to do is multiply 2 times pi times 60, and that gives us 377. So we have J times 377 for omega multiplied by the inductor value, which is 25 millihenries. And so what we do for that is 25 times 10 to negative 3, because it's milli. And then we add it again to our capacitor value, which is 1 over J, our omega is 377, times 100 times 10 to the negative 6, because it's microfarads. And what's also nice for this is that what you can do is you can actually have the 1 over J is also equivalent to negative J. So you can also write it as negative J over 377 times 100 times 10 to the negative 6. So if I were to do this first, so we do 377 times 25 times 10 to the negative 3, we would get J, let's do this to make it look nice. We get 9.425J, and then for this, we're going to get 1 over 377 times 100 times 10 to the negative 6, which gives us negative J 26.525. So now it doesn't look that difficult at this point, right? So what we do is we take our 10 ohms, so we get 10 plus positive 9.425J minus, and I already, it doesn't matter where you place the J, so let's make this look nice. So 26.525J. So these two we can subtract, so we have negative 26.525 plus 9.425, which gives us 10 plus negative 17.1J. And so that's the solution we get here. Awesome. So that's it for this video. Let me know if you guys liked it, and yeah, thank you.